Okay, so we are recording. So people who couldn't join today for their exams, please have a look at this video. So I'll be sharing the recorded video on YouTube and also on the group. So today what I'll do is, I hope I'm audible, right? So what I'll do is, I'll be trying to introduce the solution to what is called the problem of a SVM. So in the SVM, we saw how we introduce a large margin between the positive and a negative class, and how we were able to separate them into two classes with a large boundary between them. So there was a larger boundary that we enforced between them. But this was the positive class, and this was, say, the negative class. And so that led us to this optimization problem, which told us to optimize or maximize a quadratic, that is the norm of the weight of the SVM, such that these constraints hold, that the constraint given here holds. But we do not know how to solve for constraint optimization problems. That is, for all yn and xn, how to make this constraint. So our solution. So if you have x star or say w star as your solution in this case, so the constraint, that is yn w star xn plus b, must be greater than 1 for all n. So all data points, this must hold. This was the constraint, that this is the constraint. So this means that wherever you are not searching over the entire R that you were searching, R n or RD, whatever you were searching, but you search over a smaller set that is defined by the constraints. So you put the constraints and you search over a smaller set. And but how do we guarantee that we get a solution in this set only is the question that we ask. So for example, I'll give you an example to begin with. So we'll be first taking a detour, understanding what are constraint optimization problems, and then see how to solve them and apply them to the case of solving an SVM problem. So first, how do you solve a constraint optimization problem? So say you have a function f of x, comma y, and you have a constraint g of x is equal to 0. So we are first going to consider equality constraint, that is, say another function xy, say you're saying that about this function, about this function is 0 for these x comma y. So what is the value of maximum value that fx can take given that this constraints holds? That is, this equality of g of x given y, this equation holds. This is an equation, and along this equation, what is the maximum value of f? So if you have any doubts, please feel free to stop me and ask. So since it's a one-on-one session today, so not a lot of people have joined because of their exams. So I'll be waiting for a minute or two in case if you do not feel any questions, I'll continue because I'll not be able to, if I don't get questions, what I can't keep on doing the same thing. So yeah, so today what I'll try to do is I was discussing that once you get a constraint optimization problem that like the one that we got in an SVM, which we for dividing the plane into two large margin classifier. So what would you do in that case is what you're deciding. So how would we guarantee that for the optimal solution of W, these constraints hold? Normal derivatives and putting them to 0 may not hold because the constraint space may be a subset of the total space. So we need to find the optimal solution given the constraint. So let us, for example, take a fx to be a function that you want to optimize over x and y. So the variables here are x and y, but you just can't maximize it. You are told to maximize it only at those points where another function is 0, right? So let us take a particular example. and try to understand this. So for example, say we are being told to maximize x plus y, right? Given that x squared plus y squared is equal to 4. So what is the constraint? Let us draw here first. So the constraint, what does the constraint say? The constraint says that on this curve, C, say the curve C, which is the constraint, you want to find the maximum value of x plus y. So what does x plus y equal to x squared plus y squared equal to 4 look like? It's a circle, right? This is the constraint that you have. This is your constraint curve. This is x squared plus y squared equal to 4. And now you are told to maximize the value of x plus y. So it's for this problem, it's pretty straightforward, but let's see how to do this for a more general, for this case in a more general form. So what is x plus y look like? So if you have seen, we have discussed our contour plots. What does x plus y look like? Say you x plus y equal to c, you fix c, and then you keep drawing these lines, right? So in 3D, they will be like, they will increase, right? They are all these values. So c equal to 1, 2, 3, and 4, and so on. It will go on both sides, right? This is your x plus y, the contour plots for x plus y. Contour plot was supposed to be the lines along which the curve was constant, right? So for all values of the constant, 1, 2, 3, 4, and so on, we get these set of lines. Now, if I asked you to say minimize this, what would you do? So rather, are we minimize or maximize? Let's check it out. So what will you do? Do you see this over here? That so this is not minimize, I think this is a maximize this. So if you're told to maximize x plus y, so x plus y is increasing in this direction, yes or no? In this direction, this is increasing, right? So this is c equal to 1, c equal to 2, and dot dot dot, c equal to 100, and so on. So if you take a line somewhere over here, you would get x plus y equal to say 100. That's what you will get, right? That's the max, that's the value you'll get. But my question to you is that the maximum value you are allowed to get? Normally, the maximum value you would get is for infinity, right? Where if you had options to put x and y both to infinity. Any doubts? So can you tell me at what point should I stop? So this at this point, x plus y equal to say -3, right? As this or not -3, let me just put it be correct. -1. So this is at this point, it is x plus y equal to -1. But is this the maximum value that it can have? It can have more values, right? Higher values than this. So what is the maximum value that it can have? Do you agree that the maximum value it can have is when these, as this is increasing to this side, to the diagonally towards the right, the maximum value it can have is when this touches the circle, right? This is the maximum value of the line, yes or no? So that's what I was trying to draw over here. So for example, say you have a curve, this curve, and say your contours increase as you go outwards. So where are you going to have the maximum value of the contour? Or in this case, where are you going to have I think in this case we will have the minimum value of the contour. Where will you
Is
have the
where
minimum? Yeah.
where the circle touches the curve at one point.
Yes, because if you see all these other points, these are greater, right? So if you see P1, this is on this contour line, C1, compared to P2 is on C2. So the the value at P2 is greater than value at P1, right? That's what we have mentioned. I have mentioned that the contour increases along this direction diagonally. So value at P2 is greater than value of P1, right? And below and before P1, there is no point that lies on that contour, right? On that curve, right? G of x. So this is G of x, y equal to 0. There's no other point, right? This side, there is no point. So only on the right are there points, and the minimum value is reached when these two touch each other, right? Similarly, here the maximum value is reached when these two curves touch each other, right? Yes or no? Because below this the values are lower, and after this they don't have any solutions. There's no point where x plus y, x square plus y square equal to 4, right? Is this clear?
Yes.
So now my question to you is, when once you get this, so what do you see? So do you agree with me that at the point of extrema can be maxima bar minima, the gradients of f will be parallel to the gradients of g, right? Gradient of f will be parallel to the gradient of g because they're touching, right? So what is the direction of the gradient? If I draw it in the green line, this is the direction of gradient of f. This is the direction of gradient of g now. Yes or no? This is the, we have seen gradient of a function f is the direction of maximum increase. We have seen that. Yes or no? This is perpendicular to the plane. This has to be the gradient is the, if you draw it in a contour plot, it is the vector that is perpendicular to the tangent plane, right? Yes or no? The gradient is the, so if you have this is a tangent plane, this is the gradient. Wherever is the gradient, you will be, that is the value around which this is going to increase maximum, right? So basically speaking, the gradient we have seen is the derivative at every, like df dy dx and so on, right? Df dx df dy and so on. And all these points are direction along which the x and y's, the coordinates increase maximally. So the direction along which the curve increases maximally is called the gradient direction. And that is in this contour perpendicular to the sort of a tangent that you can draw. Yes or no? That is exactly the tangent. Yeah, go ask. You have a question?
No, no. Understood. Means the direction which is perpendicular or parallel to tangent.
See the gradient is the direction of the maximum increase. So if you put this, so it's the tangent and the gradient, tangent plane is the gradient, right? So gradient is not exact. So if you do a three-dimensional curve, right, there can be many directions of the plane, right? There can be many directions in which you can have a perpendicular, a tangent plane. Say you have this surface, correct? They're called directional derivatives. So at a particular point, I think you have done that also. So at a particular point, you can have multiple vectors like this, right? That are tangent. Yes or no?
Yes.
Right? So there will be a plane that will contain these all these vectors. Correct?
Yes.
And there will be one direction along which maximum increase will happen. Maximum increase. That is, x increases, y increases maximally in this direction. Right? Because normally what happens, derivative gives you a single derivative gives you this direction in which the value is increasing, right? So if you have a single equation in one variable, so that if the derivative is positive, it means if x increases, the value increases, right? Yes or no?
Yes.
At a particular point, if the derivative df dx is greater than 0, it means this is along positive x, it increases maximally. But when you have multiple coordinates, there will be different values of at a particular point, different values of df dx. Yes or no? At for each of the coordinate x, y, x1, x2, x3, and so on. Correct? So there will be
Yes.
that value that the gradient that you will get, the derivative that you will get, is the direction in which all these coordinates increase, right? Derivative gives you the increase in the direction. This is the increase that you have. So the derivative is giving you x. X is the direction. So x is positive. X increases, the function increases. Similarly, if you have a stack of values, df dx1 and so on, df dxn. So this will give you the direction in which all the coordinates increase, or the function increases maximally, right? So if you want to see this, you can take any particular tangent and see the dot product with which has the maximum derivative. So basically, if you see this graph over here, there is tangent is a plane, and on that plane, the derivative you will give the gradient gives you the direction in which this increases the maximal. So basically, it is always perpendicular to the tangent if you draw it in 2D, right? Perpendicular to the tangent. Yes or no? So it is it is a bit difficult to conceive in 3D or more dimensions, but if I draw the contours, it is easier to understand. Do you agree along the tangent there is no change? Can you tell me why there is no change along the tangent?
Means for that c is constant, x plus y
Change
equals to
in del f dot the tangent. So this is the tangent, say the tangent vector t is equal to 0, right? Correct? The
yes.
function change. So similar, this is how you draw a directional derivative. So you take a direction and see how the function changes in the direction. So in which direction will it change the most? In the perpendicular direction, right? Therefore, gradient of f is perpendicular to the tangent direction. Okay. At a contour. Clear now? If this is the no change direction, the perpendicular has to be the most change direction, right?
Yes, yes, understood.
Okay. So now so that both the tangents or both the gradients have to be parallel to one another. Yes or no? F and G both have to be parallel because they're touching at that point. Do you agree?
Yes.
So this gives me the solution to the system of equations. Just see, there's also the optimization problem. So this is also there in the calculus part of your syllabus. So we are also doing that together. So now what is f of x here? First question, f of x comma y is x plus y, right? correct? And what is g of xy? This is equal to x square plus y square minus 4, right? Yes. So the gradient of f is, what is the gradient of f? What is the gradient of f? What is the gradient of f? What is the gradient? We did this, right?
Yes, the derivative means here partial.
What is it?
1, 1.
It's the stack of all the derivatives, right? So what is the gradient of g?
2x, 2y.
So it is 2x, 2 comma xy. So what did we see? They have to be parallel to one another. Therefore, 1 comma 1. So let me just 2 comma xy has to be equal to lambda times 1 comma 1. Yes or no? To show that they are parallel, these directions. Okay. So what are the values of x? X is equal to lambda by 2 equal to y by y, right? Any doubts? Now, how will I get value of lambda? How will I get the value of lambda?
Like x square plus y square
If
equals
I
to
get the
4.
value of lambda, I'm done, right? If I get the value of lambda, I'll be able to do it. Yes or no?
Yes.
So how will I get value of lambda?
Can we place in x square plus y square equals to 4?
Plus y square minus 4 equal to 0. So lambda square by 4 plus lambda square by 4 equal to 4. So equal to lambda square is equal to lambda equal to 2 root 2. Is it or root? So 2 lambda square is equal to 4 root 2, right? Yes. Lambda is equal to plus minus root 2. Correct. So x comma y is root 2 by 2 root 2 by 2 or minus root 2 by 2 comma minus root 2 by 2. Yes or no? Agreed?
So that should be 2 root 2 now.
Oh yeah, yeah. Is it 2 root 2? Yes. 8. Correct? So x comma y is root 2. Sorry. Right? These two values. So what is maximum of fxy? This is equal to 2 root 2, right? Which is x plus y 2 root 2 and minimum of f of xy is equal to minus 2 root 2. That we could have seen from the picture itself, right? At the point where this was touching, that is line and this circle had only one solution is the point where you got the minimum and the maximum, correct? Any questions?
Means that for the solutions, each of the cases you check the values and found out the maximum.
Exactly.
So,
But in convex functions, we did not need to do anything. Why? Can you tell me? Here, we don't know. Here we convex convexity because both are convex functions here, right? X square plus y square is a quadratic, so quadratics are convex. So even the maximize is the convex. So these are, so if x comma y was greater than 0, we could have simply used convex properties and done that. But if it is not convex, it is a general non-general formula. So the second order test if minima or maxima is non-trivial. That is the problem of, so this is called, these are called, this lambda is called the Lagrange multiplier. It's called a Lagrange multiplier. Right? It's called the Lagrange multiplier. So why is it called the Lagrange multiplier? So we'll see because Lagrange found this, and why are it called multipliers? Because this helps you remove constraints from the equation. So how do you, so is the solution clear? Then I'll go to the next part.
Yes.
So you get the maximum solution. This is this you say this is the maxima. And that has to lie on the point where these two curves touch. So do anyone has any questions? Pushmit, you understood, you joined a little late.
Yes, sir, I am understanding.
So the places, so if you have understood, see, now I have told you maximize, say x is a vector now, f of x such that g of x is equal to 0. This is what the constraint is. So we can also write this as some Lagrangian of lambda. This is called a Lagrangian. Right? Which is fx plus lambda times g of x. Okay. So why can I write this as? Can you tell me this form? Why is this true? And there is no more constraints. No more constraints here. Any idea why can I write this? Pretty simple. At optimality, what happens? Of any function?
Gradient is 0.
This is 0, which is showing Lagrangian is equivalent.
Then the gradients will become like proportional, so it will become parallel.
Yes, to equivalent to F parallel G. Very good. Which means clear to everyone? So now gradient of F is parallel to gradient of G. Agreed? These two are equivalent, right? We'll see why is this formulation important. So this is called the Lagrangian. This is very, very useful because you have removed all the constraint optimization. Now you can use your first order derivative principle, putting it to 0 and finding the x values, right? Okay. This is called the multiplier. Okay. So now I'll do another question that will help you better understand. So the question says that let there be equation of a plane. So you know the equation of a plane, ax plus by plus cz equal to d. Then minimize the distance d such that it is the Euclidean distance between a point on the plane to any point outside the plane or any point in R3. Right? So it says that question 2. So you have a plane like this, which is defined by the vector a comma b comma c, and you have a point x naught, y naught, z naught. You are told to minimize this distance. Say this is x comma y comma z. We have done this in linear algebra, but which is the minimum distance here? If I write this as d,
distance.
what will be the minimum distance of this line to the plane?
Perpendicular.
The perpendicular from the point to the plane. Your class 11 and 12 knowledge. Okay, so but now, how do I do it in this form? So what is my objective here? Can you tell me? I'll just do a little bit of a cheating and I'll say minimize d of xyz as x minus x naught square plus y minus y naught square plus z minus z naught square, right? And what is the constraint that you have? Subject to, what is the constraint? So this is the
So
objective.
XYZ
X by plus
satisfies
lies on the plane.
Okay, ax plus by plus cz equal to d. This is your constraint, right? Clear? So from this diagram, we have come down to a understanding how we can relate a constraint with the original objective. So if this is true, now what will I do? Gradient of d has to be parallel to, or say some lambda times. Let me write this as g of x, y, z. Yes or no? Do you agree? Any doubts? So if there is no doubts, what is the gradient of d square? What is the left hand side?
2x minus x naught, 2y minus y naught,
2 into
x minus x naught, y minus y naught, z minus z naught.
x minus x naught, y minus y naught, z minus z naught. Clear to everyone? And what will be the right hand side if someone else can tell me?
A, then B, then C.
Okay, good. So I'll just write this once more time. And from now onwards, you should be knowing what is a gradient. You go back and please revise why the gradient is the direction of the maximum increase. I have done this once and I showed you today again, right? Because the tangent is the direction where there is no increase. I'll please go back and see something called as a directional derivative. I couldn't cover it in great detail. In multivariate calculus is not really a part of your syllabus. And I don't have that much time also. So if you could please see directional derivatives and you will understand what does gradient, where does gradient come from then? And why is it without contours also you can be able to see why it is the direction along which maximum increase happens. Okay, so now I know three equations and I have to find the value of lambda again. How do I find the value of lambda? Step one.
Substitute in the plane.
Okay, tell me.
If first we calculate x and y and z in terms of lambda and then put the point in the plane's equation.
Good. But can I do it more easily? I have found out a easier way to do it. That's why I'll do it that way. Like you can do that as well. You'll get the same solution. You're very right. X comma y comma z, you'll put lambda in terms of and then put in plane equation and you'll get it. So, but there's another simpler way. See, if I square this on both sides, and add them, what do I get? I get d square, yes or no? Yes. I get this. This is one thing I get. Okay. What else can I do? I can do another nice thing. That is, I can write x minus x naught is equal to, as you're saying, putting it in the plane. Let's put it in the plane. How will I do it? Y minus y naught, z minus z naught. Okay, how do I easily put it in the plane? I'll just multiply both sides by a. This is one equation 1, and this is equation 2, right? Okay, what do I get now? So you will get the d squared directly now. This is why I'm telling. However, যোগ করলে adding
left hand side would be like d minus ax naught minus by naught minus cz naught
good
equal to d square. Equal to
not
d
d
square by
square
2. No, sorry, so lambda into
equal to lambda by 2 into
yeah,
a square plus b square
yes,
square
yes, yes.
plus c square. So I'll get this ax naught minus by naught minus cz naught, and I'll get this as lambda by 2 as, so this is d. You told me to put it in the value of the plane, so this is d, and this is the value of the, what is this? The value of the
Like the
by
point
2.
which we are considering.
Yes, so g of x naught y naught z naught. So you can just, right, and I will just minus d plus d, right? So this part is g of x naught y naught z naught, right? Agreed? Remember what I wrote g as? This entire thing is g. Happy? I'm taking the d. Some books will not take the d. Your class 11 and 12 will also not take the d. So d minus this by a square plus b square plus c square. D is cancelled. Therefore, lambda square by 4 is equal to g square x naught y naught z naught Okay, I'll just put the value over here. I get lambda by 4 at the optimal. G square x naught y naught z naught into this. This is at the optimal point, D star. Correct? This looks like your equation that you had learned in your 11 and 12. Yes or no? You put the value of the point in the plane and then divide by the intercepts or the coefficients of x, y, and z. Sorry, not the intercept, coefficients of x, y, and z, the slopes. Right?
Yes.
No, any questions? Okay. So now what happens if there are also inequality? So in my question, I also have inequality constraints, right? Remember, in your SVM problem, you also had your greater than and lesser, like greater than equal inequality constraint. So what will I do if I am given these inequalities as well? So these become, so I will write it in a general form. Say your general case where you want to optimize for f of x. Now we'll just consider f of x, h of x, and Lj of x to be convex. Right? So what happens to the intersection of a two, like, so you have R, right? and these functions are, so these are convex. So intersection of two convex sets is, what is the intersection of two convex sets? Convex sets, I said, what is a convex set? So if theta x1 comma x2 belong to a set S, theta of x1 plus 1 minus theta x2 belongs to S as well, right? Where theta is between 0 and 1. So anything between the line, anything joining these 2 points must belong in the set. So clearly from the figure, what will it be? It will also be a convex set, yes or no?
Yes.
So intersection of convex sets will also be a convex. You can just put it in this equations and see. Why will it be a convex set? See, f of x, say theta of x1 plus theta of x2, 1 minus theta x2. What will this be? F is a convex function, I have said. So what can I write? Is less than equal to. We have seen this in convex function. Theta times x1 plus 1 minus theta times. Yes or no? That is a line always exists above the curve. That was the x1, x2. We saw this, right? We didn't see this. Correct.
Yes.
By midpoint theorem. So f of this, say x tilde is of course lesser than taking these points and taking them average, right? It will be always below the curve. The line joining them will be above the curve. Okay, so this is greater than 0, less than 0. This is also less than 0. So what is it? This is also less than 0. Yes or no? So all convex functions will have a convex solution set. Correct? So X is a set. X is the set of points that satisfy this constraint, this optimization problem. So then it is a convex set. If your f's are convex, these are convex functions. If hix and lix is already a inequality, lix and fx are convex functions, then unique minima exists, right? Do you agree? These are all convex, 3 convex sets. So therefore, the intersection of them, the solution space will all be convex. Therefore, you will have a unique minima. We have not even gone into the question that we are asking for the time being, but we're just saying they'll have a unique minima, right?
Yes.
You have any doubts? I'm free. I can explain it in a different way as well. You can feel free to ask. This is just showing for convex functions, solution space is convex, right? So each of these will give me one convex space. So what is the, say, this is S1, S2, dot Sm, S, let me write T1, T2, Tn. So what will be the set in which you will be finding your solution? Can you tell me? And we have shown S1, S2, Sm, T1, T2, Tm are convex sets. In which set do you find a solution? You will find it in R intersection SIs. Correct. This will be the set in which all the set in
R
which
is range of F.
all constraints are satisfied. Yes or no?
Dada, R is range of F here.
R is real numbers. R, whatever is the dimension of X. Say R d-dimensional. Right. And these are, you can also think of range of X. Range, no problem. Range. Or the domain, not the range, right? You find the minimum in the domain, right?
Understood.
So it's in the domain of that, whatever is in the domain, intersection, all of the other feasible sets as well. So okay, so this we showed that there will be only one solution for if all those functions fx, lx, and hx are convex. That is what I wanted to tell you. So now in whatever we'll be dealing with, whatever you deal with mainly in machine learning and constraint optimization are all convex sets. So if they're convex sets, what can I do? So you can, so till now we were writing a single Lagrangian, right? But now you have so many constraints. What will I do? I'll just add all the constraints in hix plus j equal to 1 to m beta I lix. Okay. This is my new, this is the Lagrangian I'll get. I'll come to its properties, but is it okay? Normally, if you had one constraint, it's still going to hold. These are inequality, and these are from equality. Any doubt? Any questions? This is the same thing I did in this case, right? F plus lambda g. And I'm going to write the same f plus lambda g since you have more than one constraint. Therefore, we'll just add all the constraints with Lagrangian multipliers. Okay. So alpha 1, alpha 2 dot 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 alpha n, beta 1, beta 2 dot 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 beta m are, they are real they are. So we'll say alpha i's are greater than 0. For a reason, I'll tell that for otherwise later in a while. Beta I are also greater than 0 are Lagrangian multipliers. Why do they have to be greater than 0? Can you tell me? If alpha I was less than 0, what would have happened? If alpha i's were less than 0, what are the values of hi's? The functions hi's? These functions?
Negative.
Negative. Correct. So had these values been less than 0, then what would you have done? So this product would have become
Like
positive.
inequality gets changed.
This would, yes, it would have changed the inequality, and this would have become positive, and all the subsequent, it should have become positive, and all subsequent steps subsequent steps will not hold. So we'll show we would not want that to happen. We'll see why. But roughly speaking, since you want to minimize this value, you want to sort of actually minimize the HIs because you want to see how much. So they have to be less than 0. How much this value can go. At most, it can go to h of like positive to 0, and then we'll see what is going to happen. I'll just not try to burden you with that information just now, but just let us do an example, and then I'll show you why is that not going to work. Okay. So let's see how to do this. So I'll give you one example. Say you want to minimize 2x plus 3y, given that x comma y greater than 0 and x plus y greater than equal to 2. So this is a simple problem. You can solve it in a few ways. How? Say you have this equation, right? X plus y greater than 2. So but then what do I need? I need to minimize that value using these constraints. So how can I bring 2x plus 3y into this equation? In this equation, can you tell me? How can I make x plus y into 2x plus 3y? So I multiply, say, both sides with 2. Right? What do I get? 2x plus 2y greater than equal to 4. Correct? Yes or no?
Yes.
And I know y has to be greater than equal to 0. Right? So if I add these two equations, what will I get? 2x plus 3y greater than equal to 4. So the 4 is the minimum value. So this should be minimum is 4. But these why we are using in this constraints and so on, we don't require all these combinations or permutations. For example, there's a simple way also to using linear programming to solve this. That is, you take a plus b equal to 2, right? And then you take a plus c equal to 3. There's a reason I'm doing it, because I want to separate out the constraints. You'll see how this will separate this out. A generalized form. Now see, a plus b x plus a plus c y. What can I write this as? A into x plus y plus bx plus cy. Yes or no? This is what you will get.
Yes.
So now what is this? This has to be greater than or equal to 2. This has to be greater than 0. This has to be greater than 0. Correct?
Yes.
I have been able to separate out the constraints. So I'm going to get 2a. It has to be greater than or equal to 2a. So now what can I do? I can sort of maximize this. So this is my objective O. Let me write L of x comma y. But now I have been able to write it in terms of A, right? And do you see the 2a is always less than L of xy? Yes or no? It's always less than, because I have put these constraints. X plus y is greater than 2, x is greater than 0, and y is greater than 0. I have put down these constraints and I have seen that L of xy is greater than or equal to 2a. Right? So how can I get the maximum value of this? Like the minimum value of this, how can I? So I have to get the value of a. Thus the right hand side is maximized or minimized. When will this equality hold?
Or when L is minimum.
Exactly, where L is minimum, but I don't know L, I know only A. So what can I do with A? I want to change
then
A.
we can increase it, maximize it.
Yes, we keep on maximizing it. maximize it. So maximize 2a such that a comma b comma c greater than 0. Again, I'm going to write a comma b greater than 0 and a plus b equal to 2, a plus c equal to 3. See, now b is not in this equation. So I can just put b equal to 0. And I'll get 2 into 2 equal to 4, right? This equality constraint that came up made my life much simpler, right? Instead of the inequality constraints. Yes or no? Since b is gone, 2a is there, I can put b to be 0. If I put b to be 2, it will become 0, right? 2a will become 0. Agreed? But I want the maximum value. Maximum value is reached when? When? Maximum value a plus b is equal to 2. So a is equal to 2 minus b. So maximum of a.
Oh, like b should be 0 then.
Yes, is equal to
As
2.
greater than
So b.
equals to 0.
Yes. So this is a very, very special case. But in our case, we'll have to solve a more general case where you will have any number of constraints, equality and inequality, and we want to get the values of x, that is the optimal value. So let us try to understand. This is called a dual solution. This is called a dual formulation. And this is a special case of the dual formulation. I will try and make a very general case of this dual formulation. So first step is I'll show you now why this alpha is have to be greater than 0. Pay attention. F of x. So I know my Lagrangian now, right? This Lagrangian formulation is clear, right? From the equality constraints, I made them parallel, brought the lambdas and made the Lagrangian. Is that clear? Can I go forward?
Yes.
So for all these constraints, now I ask you the question, for all these constraints, what is going to be the right hand side? So do you see that this has to be less than 0? The third part has to be equal to 0. The second part has to be less than 0, right? As hi of x is less than 0 for all I. Correct? Ujjish.
Huh.
Oshmi, is it okay? That why is the second part 0? Greater less than 0?
Yes, yes.
Tell me how?
Mm, Thinking.
Did I ask now when you were not understanding? You
Can you
had
just
told me.
explain once more?
You had already told me the reason. All these constraints, all these multipliers are greater than 0, I'm telling you.
Hmm.
But what is the initial constraint? hi of x is
Less
less
than
than
0.
0.
Yes.
Li of x is equal to 0, right?
Hmm. Hmm.
So just if you see the value, Li of x is equal to 0. So this equation has to be equal to 0.
Hmm.
The third part, Li of Lj of x for all x in the solution space has to be 0, yes or no?
Yes, yes.
Similarly, hi of x in
Less
all
than
these
0.
is less than 0.
Hmm.
Good. So what do I know? I know alpha, beta, x, right? If x is in the feasible set. So let us denote the feasible set that we have defined over here. as f. If f is in the feasible set f, then L of alpha beta x has to be what? Greater than or lesser than f of x? Tell me. So the right hand side is lesser than f of x because you're adding a negative number to f of x.
Yes, yes. Right answer. Yes, yes, yes.
The right hand side for x belongs to the feasible set. The right hand side, because L is f of x plus some negative number.
Yes, yes, yes. Understood.
So that it has to be less than f of x.
Mm-hmm.
Now my question to you is, do you also see f of x? So I'm writing this again. Now what I'll do is, I will, if I minimize over x, since this is a convex function, I'll get a minima. So this will be a function of alpha and beta, yes or no?
Yes.
So if you're not following, please tell me. So L is there, but x is a variable. So if I minimize over x, then it has to be lesser, even lesser than that, right?
Yes.
So it's the minimum value of x. So say that is at x star. So I will write this as, so this has to be less than equal to L of x star alpha beta, correct? I mean to say that this has to be less than or greater than equal to minimum of x, L of x alpha beta. Yes or no? So if this is one function of 3 variables, but I'm saying one variable I'm removing by take the minimum value. So at all other values, it will be much more than that, right? So I'll give you an example. Say f of x is equal to x square, right? So do you agree f of x is greater than 0? Right?
Yes.
Yes, yes.
So which means it is the minimum of x square. F of x has to be the minimum of, has to be greater than the minimum. Minimum is defined as the minimum value. So anything other than that has to be greater by definition. Now, therefore, I have this very nice formulation. Once I name this as g of alpha beta, right? So this I say as g of alpha and beta. So this I call as the dual formulation. We did this right just now, but this is in the general case, dual of the initial problem. Understood? This is called the dual of the initial problem because there is no x anymore, but only alpha and beta. So now see, the right hand side and the left hand side are independent of their variables. So left hand side is x, variable is x, right hand side variable is independent of x, right?
Yes.
Yes or no? So I can maximize this now and still this inequality will hold. Yes or no? Because the right hand side is less than for all xy. This is for all alpha beta, right? Once you get this, now you'll feel so nice. So this is true for all alpha beta, but then the maximum, it is true for all the maximum also. Yes or no?
Yes.
So I can write f of x is greater than equal to max of alpha beta, mean of x, L of x alpha beta. This is the way you solve constraint optimization problem, general constraint optimization problem. This is the dual solution. And this is called the primal. Where is it? Where did I write? Where did I write? This is called the primal solution. Primal. Primal question or the primal setup, and its solution is the primal solution. The dual setup and its solution is the dual setup. Dual setup and its solution is the dual solution. Okay, so this is the dual form of the primal. Correct. Now you may ask me, Dada, what is the use of this? It is always less than only. But I'm not going to get F star, right? Do you agree that you need the equality case? F of X star as the equal to alpha beta max, then you will be happy. Yes or no? If it is equal, then you will be happy. Yes or no? If this was true, I'll write again. If this was so, right hand side and left hand side are independent of one another. I can keep on maximizing alpha beta, and in the left hand side, I can keep on minimizing x. But if x has to be in the feasible set. But that constraint is not held in the right hand side. Only alpha and beta has to be greater than 0. Right? So my question to you is, will you be happy if they're equal? If they're equal, why will you be happy? Can you tell me? So see, what is the desire? This is my want, right? I want this. Yes or no? This is what I want. The minimum of the f of x in the feasible set. Is there any doubt regarding that? And there are a
No.
list of yeah, tell me.
No, understood this.
But what did you not understand? This right hand side you understood.
Just one thing to ask that means by the right hand side, we are getting the
Yes.
value of fx or the value of x.
Max and min means the value of f of x, right? No, I'm asking you which part do you want to see the value of x or value of fx?
By the right hand side of the inequality.
This inequality.
Yes. The right hand side
So
gives the value
oh,
of
sorry, it's not arg min, it's
fx.
minimum.
Okay, then okay.
Don't be confused. When you are thinking something, you tell me. It's just a printed, these things happen. Very good. So it's now the right hand side. So since I can write in this equation, there is no x and y, x and alpha and beta are separated, right? So I can separately maximize and minimize the left and the right hand side. Yes or no?
Yes.
But here you see this minimization that you have in interior is unconstrained. That is the beauty. But since you are putting this alpha beta, this is bringing in the constraint f somehow. And that somehow I saw here. Why? And now do you get why alpha i's have to be greater than 0? Otherwise, this will not hold. If alpha I not greater than 0, all the subsequent steps are invalid, right? Right?
Yes.
So, okay. So I hope you have understood this. So once you will minimize x and then you will maximize alpha and beta, that is like that we did in this case. Whenever you're having confusion, please look at this, how we generated the dual Here you did not need to generate any. We could just take a plus b and find out the dual. We could find out the dual, and then we did derive the maximum of that. So
One
my
thing to
question,
ask,
yeah,
and Dada, one thing to ask that in the unconstrained part, should we,
yeah.
is it required that alpha and beta should be greater than or equals to 0, or it starts
Alpha
from
and
the max?
beta, exactly. Very good question. But alpha and beta are they're variables. We are not optimizing yet there, right? They're still variables. So there's no question of them being greater than or equal to less than equal to 0. Once you remove x, then you optimize for alpha and constrain them to be greater than 0.
I mean, step by step doing. Okay, understood.
Exactly. And that way we'll see in SVM. Once you see the SVM now, the formulation, you will be like, what is this? Like, how can I solve this in this form? Such a complicated. Do you agree that this is such a complicated question to solve that we have over here? I have changed the slide location, but it has not yet come to the screen. The optimization problem that we had for the SVM, that is minimizing the. I think it is very slow today. Sorry for that. Yeah, the minimization problem that you have over a w has so many constraints, right? But how will you solve it? Because you have to satisfy all of those constraints correctly. You cannot do gradient descent when then w will not be in those constraints, right? Gradient descent will do it over r. You cannot put them back into the constraint set and so on. So there are so many problems. But when you do this step by step, you will be solving for all of them. So, but then you did not ask me this question that, but what is the use? Because maximum times it is only greater than. Equality is not only being held, then I will not get the solution, right? Ever in my life. Only if it is equal, I will get the solution. Correct? Only if the equality holds. There must be some special condition for the equality, and when it is held, it will actually help us, right? So there is some case called the Slater's condition. So this is called the weak duality, that F star. So F star greater than or equal to G star is called the weak duality. This constraint, right? This is called the weak duality. But strong duality is this. That is when the equality constraint is held. But when does it happen? It happens in a very nice case. See, it will happen when, since G is what you're trying to maximize, right? So G will look something like this. F will look something like this, right? F will look something like this. If and only if they merge at this point, will you have them equal, right? In case of strong duality, there is, because the theorem guarantees that we derived just now is it can be lower, but equality can only hold sometimes, not always, right? Is that clear? Then I'll tell you when the equality can hold.
Yes.
So the equality only holds when if there exists an x such that h1 of x, h2 of x, dot dot dot, hn of x is less than 0, strictly less than 0. That is the inequality constraints. Strictly less than 0. This is called the Slater's condition. This is a bit involved to derive and technical. Therefore, we'll take it as a fact. Because anyways, we're not, it's better to know this when once we are doing only optimization. So we'll take this as a fact because this is not that important and not very related. We can think it as a result that we have and use it in rest of the time, because this is not really related to any of the things that you're going to do. Therefore, it's not really essential to spend one full class trying to derive the notation of analysis that you require to find out the Slater's condition. So this is what you must note, that for the Slater's condition, if f is convex and all these hi's are strictly less than 0, then there exists a point where equality holds. So we'll have to only check that if is there an x for which it is less than 0, and then we are done. Okay. I hope it is clear to all of you. How weak duality is changed to strong duality. Can I proceed?
Yes.
Okay, so with that, I'll just give you an example and then we'll go back to SVM and complete the formulation of SVM, because we have built entire foundations required to do what the SVM has to be doing. So I'll give you this example, so which says that, so SVM also has this similar form, so it will help you to understand. So it tells you minimize X transpose QX, where Q is a positive definite matrix, plus C transpose X is PSD, that is, it is symmetric. For the time being, let's do positive definite only. That is, we have seen in the previous classes that it is symmetric plus invertible. Okay, so I'm telling you, we want to minimize this subject to Ax equal to B and X greater than 0. So what would be my first step? What would be my first step? We'll do SMO. So my question is how to form a dual. The only question I'm asking you is how to form a dual. Can you tell me? What are the constraints over here? And what is the equation? Half X transpose QX plus C transpose X. You have to minimize this such that AX is equal to B and X greater than 0. X greater than 0 means all values, all X is a vector, right? X1, X2, dot, 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 XD. Xi is greater than 0 for all I, right? Q is RD cross D and X is RD. Now tell me, how do I convert it into a dual?
Then we can write that given equation half X transpose QX plus
Okay.
C transpose
So
X.
this is the objective, right? This is the objective, f of x, our f of x that we knew. Correct?
Plus
What is
alpha Ax
okay?
minus B plus alpha X minus B. This is a
Good.
this is the Lagrangian that X alpha.
X alpha. Okay. Not totally correct. What is Ax equal to B? Is it a single number or a vector? So do you agree that this is going to be, what is this going to be? Summation of, so if I just write it in terms of the vectors, right? So A11 x1 plus A12 x2 dot 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 A1n xn, similarly others, equal to B1, right? ठीक ना भूल? So how many constraints are there?
Yes.
There are D constraints, right?
Then it will be like alpha transpose into X minus B.
We'll see. So there are, so if there are, say there are K constraints here, K constraints. So there are K constraints like this, right? 1 to K, where A is R K cross D, right? There are, say, K constraints like this, equality constraints. So now It's very simple. We can do a very simple thing to put all of these into a single. So this will be something like, so let us write this in a simple format. So let me write this as AXI, right? AX1, correct? So I know that AXI has to be equal to BI for I equal to 1 to dot 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 K. ठीक ना भूल? So there are actually K hidden constraints, right? Now, Uthrich, can you tell me what will be the actual Lagrangian?
Alpha I into like AXI minus BI summation.
Summation from 1 to K, like K constraint.
Yes.
Alpha I AXI minus BI. I'll write BI minus AXI for a simple reason. We'll see, it'll just make it cleaner. Plus half X transpose QX plus C transpose X. Is there any other constraint? The equality constraints. Is there any inequality constraints?
Like beta I x greater than equals to 0.
So you have greater than equal to 0. So minus X has to be less than equal to 0, right?
Minus beta X.
So you will have to write, because beta has to be positive. So beta I xi I equal to 1 to t. Correct?
Yes.
Now, if I ask you, can you help me change this equation to a simpler equation? I think you will
You
be
can
able to
do
do
like
it.
alpha transpose into.
Very good. You have learned. So alpha transpose B minus AX, right? Beta transpose X, where alpha and betas are vectors.
K
Alpha,
cross 1.
yes, alpha is your K cross K dimensional vector, and beta is D dimensional vector. Any questions? I'll just wait for a minute or two. Okay. So now I have got the entire Lagrangian set in front of me. Now I have asked you the question, can I do this optimization? Can I do this? Can I solve this problem? Is what I ask you. What will you tell? So now this is an unconstrained case. Now I can do just dl dx, right? Remember, I have to get g of alpha comma beta, which has to be arg, not arg, min of x L of alpha beta x, right? This is the objective that I have. So first, what will I do? The derivative dl dx, what is it? And set it to 0. So what is dl dx? Tell me. Or dow L dow x. We have done this already. X transpose qx at derivative is 2qx, 2.5 cancels. C transpose x we already have done, which is C. We have also done AX's derivative, which is A transpose alpha. And we have also done derivative of B transpose X, which is beta, right? So A transpose alpha, alpha is K dimensional. A transpose is D cross K. So it's D all D dimensional. Is it okay? Everyone clear?
Yes.
We did derivative of ddx of Q trans X transpose QX. Already we have done this in which class? in logistic regression and linear regression also, right? When we were deriving the back propagation, the gradient descent steps. I hope you remember. Similarly, we have also done dx dx C transpose X as C, and we had done ddx of AX as A transpose. Because we just, how do you do this? We had shown that we expand this equation and find out all the derivatives that are there of all coordinates. Okay, so now I'll set it to 0. So what will I get X as? I'll get A transpose alpha plus beta minus C into Q inverse. Because inverse exists, I have told this is a positive definite matrix, right? So now I'll just put this back in this equation and I'll get remove X. I'll get an equation in alpha and beta, right? Is it clear to everyone? So I'll just let me write it down. You can simplify it. G of alpha beta is equal to half A transpose alpha plus beta minus C transpose Q inverse transpose Q inverse A transpose alpha plus beta minus C plus C transpose Q inverse minus C plus alpha transpose B minus A Q inverse A transpose alpha plus B minus C minus beta transpose Q inverse A transpose alpha plus beta minus. You can simplify this and you'll get a very simple equation. That is, you'll get minus half. So this goes to identity plus beta minus C transpose Q inverse A transpose alpha plus beta minus C plus alpha transpose B. This is what you'll get. Right. So this does not depend on. So next you can do maximize alpha greater than 0 and beta greater than 0. And how we do it, we'll see it in due course. Is it clear to everyone? So this is the dual. Any questions? Okay. We have solved this as well. Now let us come back to what is we were doing last time in support vector machines or SVMs. You recall that we found out the maximum margin and so on, right? And those things I'll not repeat again, but I will slightly change the objective of the SVM. How will I change it slightly? I'll just show you now. So you see this diagram that I have over here, right? So we were saying that in the previous class that the greens and the reds were linearly separable. Yes or no? You remember that the
Yes.
greens and the. But now what happens if they're not linearly separable? Then though you will not have a case where you will have large margin, right? So we recall, I'll just write down the objective of the SVM. The objective of the SVM is minimize. Can you recall? What is the objective? Let me just write down the objective. Minimize W such that Y, I'll just put I is better. W transpose Xi plus B greater than 1. This is what we had found. Yes or no? Last time
Yes.
this is the one. Okay. So I also wrote it in the top here. But now this will not hold, right, for this case where there is not linearly separable. Because you see there's green after the first red and there's a red after the first green, right? You cannot separate them linearly. There's no line that separates them linearly, right? But are we doomed really? Can we help? Can we do something to avoid this case? This is my question. So to avoid for working with non-linearly separable data with non-completely linearly separable data, we introduce something called as slack variables. We introduce something called as slack variables. What does slack variables do? Slack variables will account for this. These variables account for the non-linearity. Right? So how do we define that? I'll just show you this for the time being. So do you agree that everything in that is green should have been below this, right? So we had defined W transpose X plus B on this line should be equal to -1. Yes or no? You recall? And everything on the line on the positive side was W transpose X plus B equal to 1. Yes or no? Okay. So then say this green point that I have over here. This green point is not going to be lying on this best fit line or below it. So how do I introduce this constraint? See, there is some error that I will represent as eta I, right? I'll represent this as eta I. Not eta, this is chi xi I. I'll represent this as xi I. So tell me, if I represent this as xi I, what can I update this equation as? So for every point, I will be introducing these slacks. So if there is a slack over here, there's a slack over here. Similarly, there's a slack over here. Can I write for y equal to yi equal to negative points, right? Yi equal to negative points, can I write W transpose X plus B less than, normally what is it? What was it less than? Normally, what was it less than? In the previous formulation, it was less than -1, right?
Yes, for negative.
For negative points, we were seeing it was less than -1. So, but if to account for this change that I have epsilon I, what can I write? It will be less than. Yes or no? I'm just adding this error that I'm going to get. Right? This has to be less than this value. Because we already do not know that. So the slacks we'll have to find out what are the values, but according to the diagram, they have to be less than this, right? Whatever the error is, we'll have to account for the error somehow. And the slacks are accounting for it. I'm waiting. If you have any question, please feel free to ask. If you have no questions, tell me what will be W transpose Xi plus B if Yi is equal to 1.
Dada, like one thing to ask that
Uh,
some points are violating that thing like less than equals to -1. So you
yes,
are adding for each point the error that can happen.
yes, yes. I'm giving this error we will find. We will find. But this is a placeholder. This is like a spring. Like a spring that can expand if required, if and only if required. We will see how will we guarantee if it is required or not. এবার বুঝেছিস? If it is only that error is must, will these become non-zero? If it is not required, it will become zero only.
Acha, and is epsilon I means fixed for all the i's or it will
No,
depend?
it will depend. It
Acha.
will be different for every I. So that's why I'm writing I separately. So that's why we are saying this is the spring for every point. So we have maximum flexibility, right? Whenever there is no.
Yes.
So it's just it's xi I. I'm not writing epsilon I. I'm writing xi I. So and then if it is clear to you, you tell me what will be for the positive points.
Then 1 minus the I.
Very good. See, in this xi I is negative, so it has to be greater than. So this is the xi I that I have for the. So this is for the positive cases and this is for the negative cases. Okay. So now I am very happy. Why you see? I will multiply y on both sides. And then again, I will get the same formulation, right? This inequality will flip because it is negative, and I will get yi transpose w transpose xi plus b is greater than equal to 1 minus epsilon I. Yes or no? I multiply yi on both sides. ঠিক আছে? Correct or wrong? You can ask me. I've done this once in the last class, but I'm doing it again today. Okay, right? So I'll be solving the dual, and then next class, the last part of the SVM will be to see how to solve the dual. There's a brilliant algorithm. So why is the dual that important? We will see. So it will just take 10 minutes more to solve this, convert it into a dual, and then next class we'll complete SVM and get into perceptrons and MLPs, deep neural networks. We have completed majority all the machine learning algorithms, and we'll be slowly getting into deep learning models. Okay, so now you tell me if you've understood what is the primal objective or the primal problem. What is the primal? I know the object, I know my constraints, I know the what I want to optimize. Now tell me. Tell me, it's simple, na? Minimize. What do I want to minimize? Arre? What was the objective? You can tell me. Half?
Okay, means that
What was
equation remains the same, only this part is added minus xi I.
so subject to what are the constraints?
And this equation is a constant and xi greater than equals to 0.
And xi is a constant, not xi. You mean xi, right? This has
Oh,
to be greater
yes,
than
yes.
0, yes or no? Just see in this figure, I have already put them always greater than 0, right? Designed it to be greater than 0. But now, so I will be very happy. If I do not put any constraint on xi, I will make xi very, very big. And I will be very uttered. I am extremely happy. Why? Because you see, if I put xi to be minor, to be infinity, what will happen? All constants will hold. Yes or no? This will become minus infinity. So W transpose xi plus b will always be greater than 0. Greater than that. Right now, if xi is just this greater than 0, then I can put xi is to be infinity. And then W transpose x will be always true. W transpose x plus b is always greater than minus infinity. Yes or no? Similarly, on the
Yes.
left hand side, it will always be greater than positive infinity. I know, so the degenerate solutions will happen. So to prevent that, I also want xi is to be have an upper bound, sort of, right? ठीक ना भूल?
Yes. One thing
How
to
can it?
ask,
Yeah.
that means what you are
Tell me.
telling mathematically, is this
Hmm.
equivalent that if the green and the red points gets mixed up, then xi will increase and increase as green?
Yes. Yes. Good. From the that's how you see the SVM geometry. I want you to go back and see the mathematically also. And it will go on increasing, but if you do not put constraints on it, it will be very happy. Just put it at infinity, and then all the solution is done, right? For all W, it will be valid, right? You have to be very careful with slack variables, because once you put it at infinity, you are like everything, all W's are correct solutions, right?
Yes, yes, understood.
So to put this, I will put a penalty. This is the penalty, right? This is called the penalty. People also write this as the hinge loss, but it's okay. It's the, we'll see that in the for this formulation, we do not require this. So we are trying to minimize this. So we also have to minimize xi's, right? So C is a hyperparameter we have seen before. That how much you want to penalize the model for having large xi's. So tell me, if C is high, what can you allow? Xi's have to be small, right? Yes. C you will choose yourself. C is a constant, it's a parameter. Hyperparameter, constant parameter, which is chosen by a cross-validation set, as we have seen in the first class. Right, as C increases, what will happen? Xi's will decrease. And C decreases, what will happen? Xi will increase. Not clear? Why not clear? Ask me. Is it okay?
Means is that to minimize the penalty?
It's to minimize the values of Xi. So if you put it to infinity, is it going to be minimized? So I was saying the problem is putting Xi to be very high value will always work. But now you cannot put the value of Xi's, right? To be very high, you have to put them optimal. You cannot put them arbitrarily large. Because you are putting a penalty in the objective itself. You have to minimize that as well.
Acha, acha, means that is why C increases, so xi should decrease.
Yes. C is no, C you forget for the time being. Say C is not there. Okay, so I'm adding this xi. Why am I adding these xi's?
Okay, so the sum will be minimized along with that. Oh,
So it is I'm adding xi so that this sum is minimized along. So along with it, xi is also minimized.
yes, yes, agreed.
So you cannot put arbitrarily large values of xi's. Now you can penalize xi's more or less by putting a design parameter choice C. C can be 4, 5, 10, 0, whatever you want. Right? That's the idea. Okay. And if you put more C value, you will make xi is even smaller. If you put lesser C value, you will allow it to be a bit larger. Yes or no? Because C is the amount of penalty you give to increasing xi's. If C is very large, you give more penalty. So the object, so the what is it called? The model has to decrease. The objective function has to decrease their values of xi even more. You can also think of this as the regularization term. C is the regularization. How much regularization you want to put on the penalty? You want to make it smaller and smaller. That's the idea. How much small do you want to make is dependent on this. So, okay. My question now is, let us do the dual solution. I cannot solve this. I know that. So how will I do the dual? I'll put down the Lagrangian alpha I, beta I. Yeah, that I will do. W and B. Bole fellow, what will it be? What is the Lagrangian? What will be the dual?
Like the first part, first equation, that primal means the objective function. Uh,
Okay, W. This is what you are saying. C. Right. This one.
yes, into plus alpha transpose.
Does not yet come, but wait. I'm not able to hear you very much properly. Is this available appearing on the screen? My writing.
You have written up to xi to, then it has come.
Yeah, okay, it's appearing on your screen, but it's not appearing on my computer is not showing. Okay. You have written up to xi, correct. Next, what will I write? Plus
Like alpha I into
on my screen. I think I don't know what has happened.
your video and audio both are fluctuating.
Hello. Hello, am I audible now?
Yes, yes.
Yes, Dada.
There was some issue with maybe most probably heating. I just stop sharing and then reshare. Okay. So so this you're saying will be alpha i's. Give me 5 more minutes. Alpha i's. Tell me. Yeah. I hope I'm audible, right?
Yes.
No, yeah. Tell me then. So what will be the constraint?
Okay, minus yi into
Okay.
in bracket.
Okay. Minus yi into bracket w transpose xi plus b, right?
Yes.
And
Plus one minus xi.
good. What else?
Means I am getting two more summation parts. Beta I and gamma I
Good.
also I am
One will
getting.
be I.
Minus beta I xi I summation,
Yes.
and another is gamma xi I minus c into gamma I.
Xi I minus c into. Why do you are getting that? See, okay, you I did not write this, so this is not required. I have put
Acha,
it
acha.
over here already in the objective. You are right. If you had put it like that, you would get the same thing. Right? The third
Okay,
one is
means
not required because
if
I have
you
already put it in the objective. It's already there here. Yeah, the third one is not required because you see it's already there in this objective. Right? C
okay,
into
okay.
xi I. Yeah. Good. So I am asking you, that is clear. Now what will I do? Next step. dl dw equal to 0. So what are the primal variables? Primal variables are what are the primal variables?
Alpha, beta,
Z-
and d.
Right, those are the dual variables. These are dual. Primal are w, b, and xi I. I have to remove these variables, right? First, I have to remove these variables somehow. So let's try and remove them. So let's remove dl dw equal to 0. What will be dl dw? Primal are the original equations, original constraints, original. So originally, what is there? W is there, psi is there, and b is there, right? Hey, na?
Ha,
Lagrangian,
ha,
I
ha.
brought in alpha and beta. These are the prime. These I have to remove. So I'll do dl What will it be? Minimize over alpha w b and dl dw. What will it be? What is the derivative of the norm square? 2w. Yes or no? Correct. This will be 2 into w, or it is just w. Are you following? I just took the
Yes, yes.
derivative. Plus this is 0. Second one is 0. Then summation of alpha I. Tell me. Yi
Yes. Yi.
xi.
Ha, ha.
I equal to 1 to n. This is equal to 0.
Why did you remove the 2?
Half is there, na?
Acha, acha.
That's why I brought in the half, just to so that I can remove it at the end. This is one equation I got. Very important. I'll keep it till the end. This is one equation I got. Then what do I get? Next equation will be dl db equal to 0. Yes or no? What will I get from dl db equal to 0? Tell me. Tell me.
Okay, everything 0 except summation
Summation
alpha I
alpha I
yi.
yi.
I think with respect to B, then B transpose.
B will be just db db is the one, na? What B transpose?
Acha, 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 acha. Yes, yes.
B is a constant. B is a single scalar value. So dl db is just a one number. So only this part has B. dl db. So dl db is alpha I yi equal to 0. Similarly, I can write dl d xi I equal to what? C times d of xi I d of xi I minus I equal to 1 to n alpha I times d xi I minus beta I d xi equal to 0, which is nothing but equal to, these are all ones, c minus alpha I minus beta I equal to 0. Correct? Just see the equation. So only from here, only c will remain because you are taking derivative with respect to 1 xi I, rest all are becoming 0. Similarly, only beta I will remain because all the other xi i's will become 0, right? Because you're taking derivative with the ith component. Similarly, here only alpha I will remain because all the others will become 0 because you're taking again respect to xi I, correct?
Yes.
So I'll get another constraint, that is c minus alpha I, or I'll get alpha I is equal to c minus beta I. Now, beta I have to be greater than 0.
Dada,
Huh.
why alphas are not getting summed up, alpha and beta in this equation?
Okay. So this is xi I, right? Beta, how will it be summed up? Say if you want to take the summation of beta I xi I equal to 1 to n with respect to the kth derivative, with respect to the kth one. Okay.
Yes, it will give beta k only.
Yes, that's what there's no sum. Similarly, you will get alpha k. Whatever you will take the derivative with respect to, you will get that coefficient, right?
Oh, you are doing with respect to xi I only, na? Acha, sorry. No.
Yeah, I understood, but here it is like I just wrote the same the running variables. That's why you are getting confused, na? Sorry, Ray. I'm putting J somewhere. And I'll not put J over here. I'll put J in the other one. I'll put J here, maybe. Okay.
Yes, understood.
I'll just put J in the this equation. Okay. Okay.
Yes.
So beta I has to be greater than 0, which means alpha I has to be less than C. Correct? So alpha I has to be between 0 and C. This is what one constraint I know now. I'll use this constraint later on. So I'm just circling it, right? Beta I has to be greater than 0, yes or no? Because we have defined them to be greater than 0. Because they are Lagrangian multipliers. Yes or no? Alpha I greater than 0, beta I greater than 0, right? Lagrangian multipliers always have to be greater than or equal to 0.
Yes.
Okay, so this will wait for some time and I'll put the value of W in the original equation. So tell me what will happen if I put the value of the W in the original equation. I will get Lagrangian of alpha I as, tell me, half alpha I yi xi I equal to 1 to n transpose right. This is the first term I will get plus C into, so I'll write it as single equation, C minus alpha I minus beta I xi I. Clear? Second term. Any doubts? So I took this term and I wrote here term 1. I'm just putting the value of W that I got from this equation, star, from star, right? Tell me the third part, what will it be?
Dada couldn't get the second summation.
I'll tell you. First summation you got, right?
Yes, yes.
Okay. If you have got the first summation, then the second summation is very simple. Now, second summation comes from these terms. This term is okay. So I can write this as summation of C into xi i's I equal to 1 to n, right?
Yes.
This third last term I can write minus beta I xi i's I equal to 1 to n, right?
It's okay. Yes.
And from the third part also I can write I equal to 1 to n alpha I beta xi i's, right? Okay.
Oh, you corrected the xi I. Acha.
I collected all the xi i's. Why is it important? Because I already know that C minus alpha I beta I equal to 0, right?
Acha, it will become 0.
This term goes to 0. Very nice formulation. Just see what happens. So now in this term, what do you get? You get I equal to 1 to n, j equal to 1 to n, half alpha I alpha j. We just write alpha I alpha j. Alpha I alpha j yi yj xi transpose xj. Right? This is what you'll get in the first sum. I'm just writing the summations together and the terms together. I can do that because it's all combinations. Correct? Any doubts? If you're not following, stop me and ask me. Yeah, now ask me. What part you're not following? Which one? So this one I'm writing this as this. I can write. Do you agree? I can write. I can write, right?
Yes, that should be a yi transpose. No?
Yi's are yi's are scalar, Baba. Yi can be either 0 or 1,
Acha, acha,
or
acha, yes.
minus 1 and 1. They are the labels. Don't forget, they are the labels. In the second, so you will get other terms are okay. So alpha I multiply
Yes, yes.
with 1, and this term I open up. So I get the same term. This term and this term are the same term. And what is this? Alpha I y. You only told me this has to be 0, right? This also goes to 0. So B also is removed. See, so such a brilliant thing. There is no B in the equation. B is removed. So what do you get? You get summation of alpha I equal to 1 to n minus half. This is one full minus and this is one half. So minus half will happen. I equal to 1 to n, j equal to 1 to n, alpha I alpha j, yj, xi transpose xj. So now let us write down everything clearly and then I'll stop because I don't want to bring in the vector notations yet. I'll do it next day. So so now we have solved the dual solution. I know alpha. So this is only dependent on alpha now. Right? G of alpha,
Yes.
this is what we need. This is written as I equal to 1 to n, alpha I minus half I equal to 1 to n. And we'll see how to solve this next class. That's the most brilliant thing. Like it's very satiating once you're able to understand how you're solving this. Now I will also, so this is the objective. I will continue from here from the next class. And what are the constraints left? Constraints are, so the idea is to maximize this. Yeah, tell me. What are the constraints?
Like here, to only alpha I greater than equals to 0 and less
Alpha
than
I
c.
between 0 and c. Yes, this is one constraint. All alpha is between 0 and c. There is also another constraint. So this is list of constraints are alpha I greater than 0, alpha. So let me write it together only. Alpha I greater than 0 greater than c, such that, and another constraint is there. You know, summation of alpha I yi equal to 0. This has to be satisfied, right?
Yes.
So these are the two constraints, and I will also keep a few things in mind. That is, I will know that alpha I is equal to c minus beta I, and I will also remember. So I have W is equal to summation of alpha I yi xi, and I have already put this over here, and I know in the primal solution summation there is a constraint beta I is the part of the sum. Okay, so this is also a part of the sum that I have in mind. So this is mainly these two. I'll keep in mind. And I'll also keep in mind the primal objective. What was the primal objective? Minimize this subject to yn w transpose xn plus b greater than equal to 1 minus di and so these are the two. So this is the primal and this is the dual. And we'll be using the dual to solve the SVM. We'll see why next class. So any questions? So this you will have to, especially this dual equation you have to keep in mind. These are not that essential. So I'll just put the essential part in the bracket. Okay. Any questions? Should we stop? Do you have any questions? Okay, then I'll stop recording and I'll continue from here on Thursday. Okay.